almost each year, the world produces nearly 400 million tons of plastic and over 250 million tons of it is thrown away.
I have a feeling we have contaminated every part of this earth. I think even in the air, I believe there could be some lot of plastic particles floating around. When we first made the cellulose films, the cellulose was predominantly extracted from the plants, the trees. As we all know, the human population is growing. Now we are close to 8 billion people, and then soon it will hit 10 billion people. To feed them all, our agriculture crops has to be increased. It is increasing too. And during that process, we produce billions and billions of tons of agriculture biomass. When I realized that there could be a good significant amount of cellulosic residue in this biomass or in this food waste, I could call that is a turning point in my life. See, initially we extracted the cellulosic residue from corn biomass and we made films, and then the strengths are comparable to plastic films, and then see the film looks like this, the cellulosic residue. So the strength is comparable to plastic films. Most pleasing was once you add them to soil, it disappears within a month or two.
The annual plastic production, new plastic, is 400 million tons of new plastic produced per year. So out of which portion of it is probably 9.5% of plastics produced as of 2020-2023 data came from recycled plastic, and then the waste generated is around, as I said in the beginning, 268 million tons of plastic disposed. So almost close to 300 tons is only disposed, and about 27.9% plastic waste was sent to sorting, potential recycling, but out of that only half was actually reprocessed. Only 9 to 10% in general. Overall plastic waste which is successfully recycled is just 10%, which is staggering. Or even if it goes to the ocean, it is actually hurting the ocean, the marine animals, and also it becomes continuously, if it's staying, it becomes a microplastic and nanoplastic, and also coming back to us in various forms, right? So that's also health hazard.
The plastic, it's a miracle material. It solves so many of our issues, but however it stays put for generations, and during that process it transforms itself, it converts itself into microplastics and nanoplastics, and then those tiny particles are happily penetrating every part of our life. They're in our human systems as well. They're the good sources of microplastics. So without unknowingly we are drinking lots of microplastics and nanoplastics with every sip of water, or anything, any beverage that we are consuming.
When it comes to plastic, the only thing which is unbeatable is, the amount of the convenience factor is people don't want to give up. You don't have filters everywhere available. You have to buy that water bottle in a plastic to drink.
It takes time, but I think it is doable. It's a matter of time. Only thing is now we have to give the better options to the society. The cell phone, now you see how much plastic we are this. We cannot imagine. I keep this next to my bed. We are carrying the plastic all the time.
We can't avoid to an extent. I think we can't think of completely evading because it has been industrialized for so long, and it is very difficult to think of avoiding all the places, but at least to an extent, as you say.
For example, these glasses, I cannot avoid. These are made up of plastic.
What would be your advice you want to give for a young scientist who wants to solve some real world problems and do some change?
However, as I said earlier, we all have the ability to do something, but only thing is sometimes our abilities and our thoughts, our aspirations, they get clouded by other aspirations. We get deviated, distracted.
Welcome to another episode of Caffelogue with Naga, where we bring conversations that matter the most. As we all know, plastic pollution is one of the greatest environmental challenges that we are facing in our time today. With over 400 million tons of plastics generated globally every year, and just 10% of it is truly recycled. The rest ends up in landfills, water bodies, and even in our bloodstreams. As we search for sustainable solutions, innovation that's rooted in nature is an important way to approach this. In today's conversation, we are joined by Dr. Srinivas Janaswamy, a distinguished researcher and professor from South Dakota State University with over 25 years of interdisciplinary research at the crossroads of carbohydrate chemistry, material science, and life sciences. Dr. Janaswamy and team is pioneering a fascinating approach developing biodegradable films from bio-waste or agricultural waste like switchgrass, banana peels, avocado peels, or even spent coffee grounds to tackle the plastic crisis. He is one of the research scientist along with his team to start focusing on finding alternative eco-friendly solutions to replace plastic from molasses or biomasses, which produces films that are close to or equal in transparency as plastic or even with tensile strength. And the important point to note is those films are biodegradable and it degrades if you put in the soil within a month. Over his career, he has mentored numerous PhD and graduate students, published more than 100 international research papers. He has received several awards, including Global Engagement Research Award and David Fee Memorial Lecture Award. So, without further ado, let's welcome Dr. Srinivas Janaswamy to our show.
Thank you for the invitation. It's a pleasure talking to you. And the introduction was really good. Thank you. As you said nicely, it's much needed at this time of our time, because plastic is a miracle material, as you could see now in many sectors. It is helping us, and indeed we need that material, that strong, robust, durable material. But however, the consequences that it is offering it on human health and environmental, some of them are detrimental,
Yeah.
and that's where we need to come up with alternatives. That's what my research has been focusing for last I can say 13 years, I believe, because I started this at Purdue University, and then I moved on to South Dakota State University, and then since then we have been focusing on. We could say we are expanding this to different wherever there is a biomass that is filled with cellulosic material, we are turning them into biodegradable materials, and we are researching on this. Thank you.
All right. I know uh, looking at the volume or the amount of plastics we use on a day-to-day basis, starting from when we get up till we go to bed, so it's so much, right? So it's a constant use. We cannot live without that today, but how much we can actually avoid.
As you rightly said, we cannot live without plastic. Think of this one. The cell phone is in our hand 24 by 7. We are even keeping it on our bedside when we are laying down because thinking that somebody is going to call. What is this made up of? It's full of plastic. So this little toy or the computer that we are using now, it's also made up of good old days. We used to have all this capacitors, if you remember them. Those capacitors, big capacitors. This generation, previous generation will have an idea of those things. But now everything was replaced with transistors and the plastic tiny material. So it's a revolutionary thing. So the whole size has reduced. Now whole computational power is with us. Anything we can dictate using this machine. It's a little toy. But this is made up of plastic. This is what the plastic can do. So that's why it is really unavoidable in our life, to be frank with you. But
No,
however, some
right,
of the problems that it is offering, that is some problem that is causing, that's where we need to come up with solution. That's what we are trying now.
right. Yeah, I know. I think it's a so going through what you've been doing, it's pretty
Pan.
um,
Think of the pan. We write
yes. So
it.
there is a lot. I mean, I think whatever we are touching today, like starting, I mean, it's become inevitable part of our life. So there is definitely a constant effort consciously we have to make to look at alternative or how do we actually do something about it. Before I get into your research, I think I want to pick your brain on maybe give a snapshot of your journey and how you got into thinking about sustainability and especially bioplastics as an area of research. I know you've been in the food and dairy science for a while, so I just wanted to probably the audience to know about your journey and what you've been doing all these years, and then how you have a sparked and started to transition to do a research on bioplastics for the last 13 years.
Yeah, that's really good. Thank you. That's a very interesting question. I am a physicist, I should. So I grew with physics and mathematics. So the field that has uh, given me curiosity, and then gave me the question why and how. So I was always fascinated by the functionality, the macroscopic behavior, why certain things behave like this. And one of the physics classes, I asked this question to my professor, and then he suggested me that if you want to understand the macroscope behavior, you should have a thorough understanding about the interactions that take place at the atomic level. That stayed with me till today. To do my PhD, I went to crystallography to understand the atomic structures, and I solved a varieties of structures are inorganic, unorganic uh, molecules in their crystalline state using both the single crystal diffraction and powder diffraction principles. But however, my quest for this structure function relationship is still there. I could not, I mean, that was still not satisfied, I could clearly say. That's when I moved to Purdue University, Whistler Center for Carbohydrate Research, to work on this time on food polysaccharides, food materials. So this time I was using fiber diffraction principles to solve the structures and then try to explain their macroscopic behavior. For example, these food polysaccharides we use in on several food systems as a thickening and gelling agents, viscosifying agents. So, and that is where I would like to understand and explain the functionality based on the structure. And my stay at the Whistler Center at the Department of Food Science at Purdue University has helped me to convert myself, transform myself into a food chemist, from physicist to food chemist. So during the time when I was working on structures, I also worked on cellulose and then other derivatives. One of my colleagues, she was able to solubilize cellulose, because the cellulose by itself is not water soluble. So she was able to use solubilize it using inorganic solvents. She approached me whether I could explain it, how the solubilization is taking place, and how we could cross-link them and then try to make films out of it.
Right.
So I was fascinated and I was drawn into this area. I could say that.
I think it's interesting, right? So I think from a physicist to food scientist, and 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 from food scientists to actually taking that byproduct of the food, what we are actually consuming on a day-to-day basis, to see how something more meaningful and sustainable product, which I think it's a full cycle, I would say, right? Using consumption is one, and then what we produce it after some of the waste, how do we probably transition that into more of a meaningful product, which is actually a novel thought. So I think it's kudos to you, professor, for taking that, and then probably it's been like 12, 13 years in terms of into this research, right?
You're correct. It's nearly 13 years since I ventured into this area. So my first publication on cellulose packaging films was published in 2016. And then later I joined South Dakota State University. When we first made the cellulose films, the cellulose was predominantly extracted from the plants, the trees, because that's what we have been using for a long time. Because trees, we chop them and then get the cellulose pulp and convert them into this writing papers and whatnots,
Right.
various things. But however, as we know, the trees are forests, are lungs of the planets. The carbon dioxide that we release, they absorb and give back the oxygen. So, given a chance, we should retain the plants. And at that time, during 2016, when I started my journey at South Dakota State University, I came to know more about the plastic problems and plastic issues. People have been working for a long time. By the time we all have realized the havoc that plastic could create. So, what is the sustainable way to address these plastic issues? So that's what people have been figuring out, and that's when I thought, what is that I could do based on my experience on cellulose?
Right.
So it appears that cellulose films could be the solution for this plastic packaging. But however, the initial cellulose that I used was from the plants, and then I am not interested in chopping the plants. So that's where I was thinking, what is the best way to get the cellulose source? And that is when I came to know about this agriculture biomass. As we all know, the human population is growing. Now we are close 8 billion people on this planet, more than 8 billion, and then soon it will hit 10 billion people. To feed them all, our agriculture crops are, the output is increased. It has to be increased. It is increasing too. And during that process, we produce billions and billions of tons of agriculture biomass. And also the processing byproducts we use, we generate a lot of biomass. Even fruits and vegetables, we generate a lot of bio waste. When I realized that there could be a good significant amount of cellulosic residue in this biomass or in this food waste, I could call that is a turning point in my life. Frankly, I could clearly say. So
Yeah.
then started extracting that white cellulosic residue and then started making films.
If you made it this far, you're clearly into deep, meaningful conversations around health, lifestyle, and the science behind how we live. 60% of people who watch these episodes haven't subscribed yet. If you enjoy these insights, my humble request is to please consider hitting that subscribe button. It will help us bring much more curious minds, expert voices, and keep the show going strong. Thank you.
Yeah, it's an interesting journey, right? I think starting from another research to I think moving into something which is more probably related to it. How do we solve one problem? I mean, which is more staggering. If you look at, I mean, the percentage is, if you look at it, is such less. I think what I see from a reference data points is the annual plastic production. New plastic is 400 million tons of new plastic produced per year. So out of which portion of it is probably 9.5% of plastics produced in as of 2020 data is came from recycled plastic, which and then the waste generated is around, as I said in the beginning, 216 million tons of plastics disposed. So almost close to 300 tons is only disposed, and about 27.9% plastic waste was sent to sorting and potential recycling. But out of that, only half was actually reprocessed. Only 9 to 10% in general overall plastic waste which is successfully recycled is just 10%, which is staggering to actually think about, right? The amount of recycling is just 10% of so the remaining it just stays and then it just continue to come back to us. I think I know. Maybe you will explain it. And even if somebody says it's recycled, we need to have those equipments to actually recycle. It's not like all of them, even if it's recyclable, it's not really a human can do it at their home, if because it's not biodegradable. So you need the equipment. So that's where your research really helps, because it's important to have something which I just leave it, it just biodegrades automatically by the soil.
That's the beauty of, as you rightly said, we need to recycle our plastic, which we have been doing it. I really condemn all those efforts. But however, during this process, we are slowly producing some microplastics and nanoplastics that you,
Nanoplastics.
yes, that slip our side, and then they nicely go and then stack in the water. They contaminate our water, soil, even the air. Is some tiny particles that we are breathing. So studies have clearly shown that even in our blood, there is a lot of these tiny particles are happily floating around. There is a chance for them to get accumulated at our
Yes.
near our organs, and then the chemicals that we use during this process of producing these plastic materials products, they could get slowly released, and then that could have unimaginable negative effects. So that's where we need to come up with a solution.
You're right. So if I correlate with the other researches which is happening, especially on the toxicology, even on the non-stick coating, which the cookware we are using, so it's also like it produces a PFAS. And if, as you say, the nanoplastics, and today we can't imagine, because everybody is drinking, even on the water bottles. The water bottles are not really a good. The plastic water bottles are not really a sustainable or probably good for health, even because that it has so much of micro and nanoplastics inside, with
Maybe
the
for,
impact,
for now
just an
we'll say
impact. Yeah,
tiny invisible particles. For now, we'll say
right.
those tiny invisible particles. We'll say because, in fact, we cannot see them in the water when
You
they are
cannot see them.
happily
Yes.
floating there. So go
but
ahead,
but
go ahead.
but it's impacting their health. Long term drinking of from plastics is actually, we see that people who have a lot of lifestyle health diseases is used because of all these plastics. And even I think what I heard is even that, as you say, the Arctic Circle, even at polar bear, has the when they tested it, that's very shocking to hear how much we have damaged our ocean and marine life as well, right? So it is highly.
Many species are getting extinct, to be frank with you. Some of them, it is difficult for us to retrieve them back.
Yep,
So
yep.
we are losing a lot of ocean treasure in that sense, because all those creatures are getting extinct. Because these tiny particles, they think that is food, and then they consume, and then they cannot digest, and then they eventually get extinct. So this is where I think we need to somehow stop in some sectors, if not all.
Not all. Yes.
Food sector, I chose food sector because I'm a food scientist, not because of that, because food, we wrap everything with, in every food material now we were wrapping with the plastic films. We are, what is happening is all those contaminants that are present in the plastic, or those tiny particles, they're getting it swept into the
Leaching into the food
mixing
particle.
them, and then ultimately we are consuming, and then that is going to cause a lot of issues. In fact, one of my dreams is this one. Now I'm making biodegradable films, but however, I'm also planning to change into edible films, so that we could wrap a food metrics with the edible thing, and then ultimately you can even consume them too. But it's not that easy. It's not a scientific movie to just like that turn into, but it takes time. So this is one thing that hopefully we will be able to have an answer soon, if not me, somebody else. But I'm working on that. Edible films we're trying to.
Okay, that's interesting. I think there is one company who has done like the edible water, like Notpla, somewhere I think in Nordics. So it's just the edible water. So
Edible,
it comes like salt. Yeah.
they're making spears, water spears, right?
Yes. Yes.
Yeah, you can
Yeah.
just cut them. I know they use
Yes.
algae, and then they trap the water. And in fact, we are also using that concept for something else in our research. Alginate we are using, but they are using alginate, which is also very good concept, because it alginate that ultimately we will our body cannot metabolize, so it gets secreted out. So which is good.
Mm.
So
Mm.
water is stays in the system. That
That's
is
right.
also a very novel idea, very good idea.
No, I think it's interesting, right? Uh, Again, you started doing something of as a research, and probably during the course of the research, you try to you identify another area of interest, and it turns out to be that there is a possibility, which it can help an environment, and something which is a crisis at this point, which definitely maybe more of a aha moment, right? So which you you will get into.
which
Yeah,
is,
I can see that,
which is
Asha.
really true. By the way, this people have started extracting cellulosic residue from agricultural biomass for a long time. But I think I was the first one to use that to solubilize and make packaging films. That's where I could say it was really pleasing for me even today, saying that I
Breakthrough.
was the
Yeah.
one who initiated this one. So initially, to be frank with you, we extracted the cellulosic residue from corn biomass, and we made films, and then the strengths are comparable to plastic films, and then see the film looks like this, the cellulosic residue. So this the strength is comparable to plastic films, which was really pleasing. And most pleasing was once you add them to soil, it disappears within a month or two. That was the aha moment. We could clearly say that, oh my goodness, the plastic, we know that it stays put in the environment, in the soil for several centuries. I think it could even up to stay 700 to 1000 years. So
Yep.
10
Yep.
7 to 10 generations of us. So it could stay put that long. But whereas these films that we made, once you add them to soil, and within a month or two, they disappear. So it is not surprising, because cellulose is biodegradable. But however, we convert them to packaging films, and then there we could clearly see that there are no residues left in the soil. So that was the most satisfying and gratifying thing I could tell you.
Got it. No, I think uh, I can see the passion and the effort it would have gone into coming up with something, because research always is very it is like a probabilistic area, right, in mathematics, right? Because it's more of whether it might happen or it might not. So it's always that continuous trial and error you would be doing it. But I think that moment when it turns out to be more of a outcome which you actually anticipated and probably working too, it's definitely a self-satisfying, right? So some things, yeah.
Those moments, as you rightly said, those are really self-satisfying, highly satisfying moments. But anyhow, that's what gives the more energy, more curiosity, more. The more you know, the more questions to be answered. So, okay, now initially, once we solved the extracted cellulose from corn biomass and made films, we were wondering. So, is there a way? How could we increase the tensile strength, the strength of those films? And then also, most importantly, all these films, when we're trying to use them in packaging applications, there's one property we call it as water vapor permeability, how much water that could penetrate. For example, if you see plastic films, once you add a droplet of water, it stays fit for a longer time. Nothing happens to it, and water cannot penetrate. That is how we use plastic in packaging, and in a way, it even enhances the shelf life of the products. So our films, on the other hand, these films, because the cellulose by itself has a lot of hydroxyl groups, we call this. So the hydroxyl groups could nicely attract a lot of water molecules, and thus the films that we develop from the cellulosic residue are not water resistant or hydrophobic. So as such we cannot use them in packaging applications. So that is where we thought, okay, now it is, we have to look at other biomasses as well and see how these properties are changing. Is there something that we could tell us? It could give us a clue how we could address that issue also. And one more thing, as we all know, that plastic has a very flexible, it has a lot of
Flexible. Yeah. Right.
and whereas these films that we made, they are really strong, but they have very little flexibility, unlike the plastic, and we cannot stretch them for longer duration. So these are the two more issues, I should not say, two more points that we thought we should address, and that's when we diversified ourselves, and then we started exploring other biomasses.
So I think I just want to deep dive because you talked about this food. We can't completely replace plastic, even though you want to do that as a long term, but it definitely it's not like a easy process to, because you can't compare the kind of convenience and elasticity which plastics brings. But so at least on the food industry it is important. So like I just got some example, like so like this one. So let's say this is like every day you go to a grocery store, you pick up something of this for eating, like fruits. All the fruits are in this box. So I'm trying to understand. So I think I maybe you can deep dive into, you talked about the switchgrass, avocado peels, banana peels, coffee grounds. So all these are materials you're actually trying to use to come up with film. So is it something, maybe deep dive into one of them as an example in terms of how this could lead into probably something of this sort? I think I have noted down the three important, right? It's had to be, one is the how much is bio tensile, the tensile strength is important, and then how much is biodegradable, and probably you can add, I think there are 3 points you mentioned, right? So I think I wanted to maybe take us through an example of one of the cellulose, and then see how do you think in future, or how long it's going to take for us to go there to produce something of this box.
Okay, thank you. That's a very good question. No, as I gave you my life example how I transferred myself from a physics to food chemist, and also during the process how I started working on the packaging film, cellulose films. Initially, I started working on the corn cellulose because we took corn stalk, and then from there we extracted that white cellulosic material and then converted it into films. Okay, initially, to be frank with you, we did not almost around 2017 2018 when we started, we did not get the pure white cellulosic material. Okay, so this is initially what we did was we thought, okay, even if there is some lignin or hemicellulose, okay, so we made this film. It's like a plastic film, you could clearly see that. Okay,
Yes.
so but later what we thought, okay, why can't we completely remove all the lignin and get a pure white cotton like material, which we did, and then we made films out of it. It is not only corn biomass, there are varieties of biomasses. Are there any differences? Will there be any differences? That was the next question we asked ourselves. Then we started extracting cellulose from different biomass, like wheat biomass, corn, rice we used, and then Swiss grass and paraquat grass and corn, and varieties of systems. Then also we thought, okay, what about, for example, banana peel, avocado peel, and then we all like coffee. So once we drink coffee, the spent coffee grounds we are throwing away. So we
Right.
thought either way we could somehow make use of them. So we even able to extract a white night cellulose material and make biodegradable films. So that is the most interesting thing. And later, if you look at the properties and all of them, and even when the way they biodegrade, the rate of their biodegradation is different. As you said, any film that we are trying to make, which it should have enough strength. Because you see, now
Right.
let us say, imagine that tomorrow we are trying to make grocery bags out of this bag.
Right. Right.
So they need to have enough strength if you want to, because now if you see when we go to any grocery store, we dump as much as we could before we take it, transfer to our cart and ultimately our car. So we really want to have a resilient, very strong, sturdy bag that won't tear off. So that's why I would like to see whether our films have that enough strength. But luckily, the trees, the cellulose, it offers a very good strength. So our films also have good strength, comparable to plastic or more than plastic in some cases. For example, in the case of more recently, we made films from Cape cranes. We got or even alpha. When we made films, we got up to 17 to 25 megapascals. That's really strong. But one more interesting thing about the plastic is the plastic, as you could see, it has this transparent nature. It's a Ziploc bag. I'm trying to.
Yes.
It's a very transparent one, and then it has a lot of elasticity. But in the case of the cellulosic films, we don't have that transparency and that elasticity. Interactions and all the things, but just to be on the periphery, I can say they are really strongly bound. It's very difficult for us to like plastic
Separate
mold.
it. Yeah.
So at least they are able to provide the strength, but the transparency was not. It was it varies from film to film. But most interesting thing was when you put them in the soil, they biodegrade. Within a month within a month or two, they disappear. So
Right.
that is
That's
the most interesting and important thing, because unlike plastic, because plastic, as we know, anywhere from 700 to 1000 years it could stay in the environment, and during the process it could even get some minor microplastics and nanoplastics. They tend to create a lot of chemical. And on the other hand, here, this being a cellulosic origin, so once you put them in the soil, they nicely get broken down to small things, and then ultimately it disappears. So that was most pleasing thing. So this is how we started.
If you made it this far, you're clearly into deep, meaningful conversations around health, lifestyle, and the science behind how we live. 60% of people who watch these episodes haven't subscribed yet. If you enjoy these insights, my humble request is to please consider hitting that subscribe button. It will help us bring much more curious minds, expert voices, and keep the show going strong. Thank you.
there are products which says biodegradable, right? But then the question is how long. so so it's also a greenwashing which happens, right? For more of a everybody want to put the stamp as biodegradable, but you really need to know, like, when I put it into the soil, how long it takes to to actually completely dissolve, right? So it's I've tested few grocery bags which it says eco-friendly, and you put it's after 6 months, I said it's exactly the same. So then you have to really look at the place where they said, okay, bring it to some of them. I have where I just try to bring few examples. So I didn't want to bring the company, but then something like that, it says, food waste bags compostable, but then they're saying that you have to bring to the,
Facility.
yeah, to,
Facility.
so once you reuse, but it's not practically possible, right? So how much of that is going to be, because not individually you can actually collect it together and then go into as a process. So
On the other hand, these films, if you can make bags tomorrow, after use, if you just throw them in your backyard, and by one season they disappear, because
right,
I can
right.
once
Yeah,
there is.
even Ziploc, we have this new by I think it's eco-friendly compostable Ziplocs, but I think it's not as sustainable as what you're trying to build. So that's very important to have. Mentioned about different examples, specifically how do you moved into what I think you talked about the challenges, I think what you face, but what are the any scientific finding in terms of adoption of this? Let's say if I take switchgrass, or I think probably switchgrass, or even we do lawn moving very often. I think there's so much of waste which comes out through that, so that could be a good source. We don't have to really look for a costlier resources to actually make as a ingredients, or probably um, source to actually you build this film, but it could be as good as a lawn moving the grass which is actually going waste. How do we scale this, right? So do you think when we build larger films and then stronger, is it going to be as good as plastic, or not? I would say not equally, but at least close to. You think it's going to be sustainable from a enterprise scale?
I'm really glad that you talked about lawn grass. And in fact, we have worked on lawn grass. I know I did not mention that earlier. We have not published that result yet, but hopefully soon we'll have that publication will come out. Lawn grass is a very good example, because every summer we mow our lawn and a lot
Yeah.
of being composted. Instead, that is a very good source of cellulose that which we could extract and make nice biodegradable films. And in fact, lawn grass films as of today are the much stronger than any other film that we produce so far. Can you
Hmm.
believe it? So it
Oh,
has around 30 to 32 megapascals. That strong films. compared to anything else we got as of today.
Yeah, we just waste that, right? Because every summer, of course, there is so much of lawn mowing happens, and there is so much of grass waste. That's
You,
true.
imagine how much of grass we will be producing in just one summer cycle. Imagine throughout the US. Forget about the rest of the world. All that, if there is a way we could convert them. See, roughly every biomass, for example, every 100 grams will have roughly around 30-35 grams of cellulose. One third of that is cellulose. Sometimes it could even vary. So that means if we have 3 tons of biomass, you will have 1 ton of cellulosic residue. So with that, we could do wonders. We could make a lot of, especially in the packaging sector, we could make a lot of films, and then hopefully we'll be able to address these packaging issues. And that is what has driven that ideology is driving me to in this area. To be frank with you.
It is not just the plastic waste, but after that, the one is the emissions because of that, and also the landfills, or even if it goes to the ocean, it is actually hurting the ocean, the marine animals, and also it becomes continuously, if it's staying, it becomes a microplastic and nanoplastic, and also coming back to us in various forms, right? So that's also health hazard. Yeah. I mean, I think in that way, your research is very, very relevant at this point in time. So my next this leads to my next question is on the so there are so many different I know that you've talked about the early influence and how you shifted towards the sustainable materials, but any standout products you want to deep dive in terms of the research area, like very specifically, you felt, this is very, very important, which is actually doable from a biomass, right? How this is, I mean, the resources are available. It is also what the intention when we actually talk about plastic replacements is always, as you said, there are a couple of things which is important: the tensile strength, and also
The
the
water.
transparency, and then how much it cannot be as equal in terms of the pricing as a plastic, but at least to an extent more affordable would be the point. But as much we use the resources which are actually thrown waste, so then of course it is going to be the byproduct of that would be inexpensive, right? So maybe maybe pick up, if you want to share a couple of examples of the research, and go into a product which of your choice.
That's really good. No, no. For example, think of any biomass, corn itself. Now, after we harvesting that biomass, we are using some as a cattle field, and the rest we are leaving on the uh, on the on the field itself, which is really
Right.
improves the soil health. Okay, and on the other hand, now let's think of the spent coffee grounds. We drink the coffee and then we throw away the spent coffee grounds, and then that could be harmful to the environment because so that is where if there is a way we could recycle that and then give it as a new shape. That's what we are trying to do. And then during that process, if it could address one of the burning issues that currently the society is facing, that would be really advantageous and helpful to address these issues. Any of these biomasses that we are producing and we are using, and then we could use them and create additional value. And that is also one more of my focus because once we try to throw them in the environment and then everything gets biodegraded, we are not getting any value out of it. Instead, if there is a way to reshape it and then create some additional value, that would be advantageous to the society, to all of us for that matter, and more importantly the farmers, if there is a way we could use that agriculture biomass. And our other ways, you see, we talked about the lawn grass. Now imagine that once instead after we mow our lawn, and then we tell the house owner saying that, hey, you give us that biomass,
Yes.
we'll give you return some few dollars. That additional income, I think everybody would love it.
Even without dollar, they will give, because anyway, it's going to be getting piled in their houses.
Yeah, even otherwise they will give. No, no.
So you want to incentivize.
Incentivize so that people are more and more people are involved in this, the plastic problem we could address. That's what I'm trying to say. Because as you rightly mentioned a few minutes back, the plastic, it's a miracle material. It solves so many of our issues, but however it stays put for generations, and during that process it transforms itself, it converts itself into microplastics and nanoplastics, and then those tiny particles are happily penetrating every part of our life in our human systems as well. They're
Bloodstreams,
floating in
yes.
our, the air we breathe, they are there. And then there could be a lot of havoc, but as you see in the marine system, in the oceans, they have many creatures are extinct now because we cannot get them back. Tiny particles thinking this, many creatures thinking that they could be food, they swallow them and then they could not digest, they eventually. So, and same way in the case of humans, we really don't know. Now only we are trying to, more and more studies are coming out, because as of now we know that there are a lot of plastics floating around. So this is where we all have a responsibility to somehow address this plastic issue. I mean, one solution we all could envision is using the biomass. They're right in front of us, and then we are not really utilizing it significantly. And I believe by doing research in this and then using the cellulosic residue from this agricultural biomasses, we might be able to solve the plastic issues, if not all sectors, at least in the packaging sector and food packaging sector, where I believe we could nicely make these films and then use them for different applications. And that's what we are trying.
Corn biomass and lawn moving grasses. I mean, switchgrass is also one. And again, banana peel and avocado peel is all. Banana peel is very easily. I think every household eats banana for sure. At least even on a day one, right? So you in a week you actually have so much of waste, bio waste, which is actually available to as a resource to produce, right? Again, depending on which product we are trying to build, we can decide in terms of the percentage of strength what is required versus transparency, and that could be the composition which we can think of. Yeah.
As you rightly said, we all drink coffee and tea every day. So that the waste, the residue we are throwing away. Every summer we mow the lawn, and in that grass we are throwing away. And many of us consume bananas, and then that peel we are throwing away. So these four biomasses, for egg waste, if we could repurpose them and then try to use them to solve the plastic issues in a more sustainable way, that could be one of the uh, I don't know what you can, the easiest solution I cannot say, but that could be one way to address these plastic
Yeah.
issues.
No, I think it's you are doing it in a way, right? It's just that probably the turning point is always when we kind of break through that challenges what we have. So my next question is leading to that actually. What were the key challenges in this area? Maybe you can talk about it, but maybe my question is one is the science part of it in terms of making it better. So maybe you can throw light in terms of where we are lacking at this point, and also the funding perspective. Is it still how the funding is actually, right? And then the last part is on the adoption. So maybe you can throw light on all the three.
We made films. Those films are really good. They have a strength comparable to plastic, but as I said, there are some small glitches, the limitations, and the strength is not higher than the plastic films, but however they don't have the elongation, and also the water, because the films, they tend to be soluble, they tend to absorb water. So the first immediate challenges that we have are now make them more flexible. The film should be more flexible like plastic, and
Right.
also
Right.
and increase the transparency. I believe we are almost there. We are trying to increase this transparency, which I'll talk in a minute. But the water vapor permeability, because we have to make them as more hydrophobic, so that the films once,
Right.
and then I think we could really say my films are close to plastic.
Hmm.
And that's where I believe when we used grape canes, we believe to some extent we were able to, were successful, because the films from the grape canes, when we made them, they are around 80%, more than 80% transparent. They're more like plastic films.
Wow.
The strength is also very high, but once again, they're really strong. They're not flexible. So at least one aspect, the transparency we have addressed, but the flexibility we need to increase, and then and also the water vapor permeability also has to be reduced so that
Correct.
it
I think there
becomes.
are three important characteristics you mentioned in all your research too, which is important to measure.
Interestingly, the grape cane films, compared to all other films we made, the moment you add them to soil, within 17 days, it disappears. As you're aware, these grape canes, once after they harvest the grapes, they are thrown as waste. But whereas now, when by repurposing them, I believe we could create a lot of value to this, and hopefully the farmers also will be able to get some extra income out during this process. But that will take time. And the one more question that you asked me about was the how we are trying to
The funding aspect of it, right? Yeah.
funding aspect. Funding, I believe we have a lot of funding, because now as of today, I got some more than $800,000 from different funding agencies, federal grants, state grants, and then commodity groups are very much interested. We need some more funding, because based using this funding as of today, we could solve the issue at the basic level, laboratory level. We proved. See, for example, now this film, if I had to convert them into a packaging bag, grocery bag, let us say, so if you had to go to that pilot scale, industry scale, that's where we need large and larger amount of money. Private agents also very much interested in addressing the plastic issue, because people have realized, consumer to higher level, everybody has realized the havoc the plastic could create, and that's why they want to move away from plastic. So they are trying to come up with looking for the alternatives, and that's where I believe we'll have more and more support in the near future.
Some researches are not, I mean, all the research which is actually for a betterment of the society and environment in some way. That's why the research is all being happen. But certain research is actually more of a breakthrough, right? Because what you are doing is one such where it is not just touching one domain or two. It's going to actually have an impact across the globe on all the areas. It's because today plastic is penetrated through every single domain you can name it, right, from screws to anywhere. But I think, as you say, we can at least food industry is an important industry where if we have a sustainable alternative, that's going to actually reduce the health hazard too, because today with the lifestyle and the changes, there is so much of health complications and diseases which a lot of idiopathic ones we have got. We don't know the cause, right, through water. And the bottles has so much of microplastics and nanoplastics that just, I mean, what I understand is even if there's any impact to the water bottle, just crush it, it's going to produce so much amount of nano and microplastics. So but nobody stops drinking it. So I think there is a microplastic, as you talked about, and I just remembered there is a microplastics test kit which has come to test your blood, how much plastics you have, and then you can consciously take an effort to reduce by regularly. I mean, I take my own bottles to the coffee shops today, like the steel cups, because the cups are coated with plastics.
They're the good sources of microplastics. So without unknowingly, we are drinking a lot of microplastics and nanoplastics with every sip of water or coffee or anything, any beverage that we are consuming. That's the irony. But anyhow, now the general public, I mean, I think they're well aware of the consequences, so that's why they're also trying to move away from this. And that is where I believe, as an academicians, and then we all have the responsibility, not only me, you, and then government officials, because everybody has realized the concerns, issues of the plastics. Then what is the solution? And that's what we are trying to do, come up with the biodegradable packaging films, but there could be something more. But ultimately, we need to show that solution to the consumer. And I'm pretty sure once we do that, they will accept it easily.
If you made it this far, you're clearly into deep, meaningful conversations around health, lifestyle, and the science behind how we live. 60% of people who watch these episodes haven't subscribed yet. If you enjoy these insights, my humble request is to please consider hitting that subscribe button. It will help us bring much more curious minds, expert voices, and keep the show going strong. Thank you.
See, when it comes to plastic, the only thing which is unbeatable is the amount of the convenience factor is something which people don't want to give up. I understand that even from a food standpoint, right? If somebody wants to just today, nobody wants to cook, so the convenience is actually buying the food off the shelf, right? So how much is it impacting your health? It's a different question. I mean, shops or the uh, places where they're selling the food could be, they can think about even making the fast food more healthier. That way, the convenience is not compromised. It's not only individual consumers' responsibility. So that way, as you say, when I have an appetite to change from a plastic cups to something, but I'm not able to get that on a regular basis because the convenience. But let's say when I'm traveling on the go, I'm not brought my cup for a reason, because not all the time, sometimes you carry, or probably you don't have water bottles all the time, sometimes you miss it, then don't have filters everywhere available, you have to buy that water bottle in the plastic to drink. So it's the trade-off we have to work on. Yeah, but I think
But it takes time, but I think it is doable. Because you see, imagine good old days when we don't have these plastic pouches, plastic bags. But now later we found out this is convenient. That's why we conveniently we switch it to plastic.
we switched back. Yes,
Everything made of the plastic. It's a matter of time. Only thing is now we had to give the better options to the society.
right, exactly.
And once we do that, I believe consumer will switch because we had to everything. It boils down to economics and convenience. Yes, you could.
True, as you say. Yes, that's
So
right.
now only thing is now our research it has to be further improved and then make sure the product, the films that we are able to produce, the price matches with the plastic bags, so the consumer will automatically switch. See, for example, the cell phone now. You see how much plastic we are. This we cannot imagine. I think many of I keep this next to my next to my bed. Okay, so this we start with this and then whole day it is with us. We are carrying the plastic all the time, and whole world is in our hands. That's what we could clearly say, that whole world is in our hands because we could do everything with this. But if there is a way we could somehow replace all these products with the biodegradable materials, I think hopefully consumer will move to that. But that may take time. But even as I mentioned earlier, if not every sector, it would be difficult to replace the plastic. But at least in the packaging and where we are using to store the food for a longer time, or even single use, even for shorter durations, if there is a way somehow we could use this non-plastic or more biodegradable packaging systems, bioplastics, I think that would solve a lot of issues, mainly because the single-use plastics are heavy, high, because we are
It's
using
very high. Yeah, I think
millions,
it's
millions of tons we are using them. And then that if you could minimize, hopefully we'll be able to reduce last a significant amount of waste.
yes, especially the single-use plastics is an area where there is how much ever invention you could do, it is not enough, because there are so many places we are using single-use plastics today. So unimaginable waste coming out from single-use plastic, right? And it's just as you said, it's out of sight, out of mind, but it is not out of it is out of your mind, but is not in sight. It will come back to you.
Is coming back in a more profound way, because we think that
Yes.
see now people have been using these plastic bags, you throw it away, but what is happening, it is happily getting stashed in the in the soil, or getting mixed up in the ocean, and during that process it converts to microplastic, nanoplastics, and then they are coming back in terms of the water we drink or the air we breathe. It is with us, so we have to deal with issues that it is going to cause.
In the Arctic, the polar bear has microplastics in the bloodstreams, or the PFAS, which is actually generated from the coating which is on the non-stick, right? It's because everybody uses non-stick. So the non-stick cookwares are actually carcinogenic.
Yes.
So not many people, are aware, because it's a fancy non-stick. Everybody wants to, but it's okay to the food to get stuck in the iron or steel, because that's still good for your health than non-stick, which actually is injecting all the PFAS chemicals into your bloodstream. So yeah,
I have a feeling we have contaminated every part of this earth, every part, because with the plastics and microplastics. I think even in the air, I believe there could be some lot of plastic particles floating around. So that's where I think we need to be more cognizant and then try to come up with the alternatives.
I think when we maybe in 10 years down the line, when we the babies are born, when you test the bloodstreams, of course the mother's milk is the breastfeeding would have the traces of micro nanoplastics too, because the way in which we are the environment is getting polluted is like, I think it's so dangerous now.
There are chances because rat studies have clearly shown that through mother's milk, new babies could get the these tiny particles, the nanoplastics. So there is every chance newborn babies could get this plastic particles. So that could be. a lot of devastating too. And that is where it's our responsibility to come up with alternatives. There is no point in asking public not to use any more plastic. It's difficult. It's very difficult. So we need to come up with alternatives.
Every individual, as of today, we have a responsibility of actually reducing the carbon footprint as well as reducing the single use of plastics, because we can't beat plastic pollution, because that's a UN theme for this year, right, in the world. Individually, if I'm not able to, if in every person not taking action to not use single use plastic, we will not be able to beat that plastic pollution forever. So we have to consciously avoid as much possible to an extent. But of course, as you say, that sometimes we have to compromise on the convenience, and we'll have to help the public to actually choose the right.
We provide them the alternatives. As long as you are able to provide them for example, now when you go to grocery stores, we have those grocery bags. So we think that, I mean, there are plenty of them, and then we just like that grab them. We are not paying them. In fact, that money is also added to the
Added to the
pay. But general public will think that, oh, everything is free, so you can grab as many bags you want. But if there is a way you could replace all those plastic bags with the biodegradable bags, and that would be the solution, and consumer will definitely switch to this. See, this is what we all did. For example, dietary guidelines, and for last several decades, we have been educating the general public about the benefits of eating good, eating healthy. So we are seeing all those benefits now, because as you could see now, our lifespan is increasing. The people are really healthy, and then current generation is, I mean, they are not ready to eat any food that they see. They are really looking at the calories. What type of, which one is contributing more calories, proteins or carbohydrates or fat? So they are really choosing. So which we are seeing the benefits that we started a couple of decades ago. We are seeing the fruits now. So now, and if you see the health of the society also has increased. Now, the mortality, if you look at it, our age has increased now, because in some society we are seeing people living up to 100 and more, healthily. That is what is more important. Now we see presidents at 80 years, 70 years. It has become like a common thing, because of we are really strong. So this is all the effect of the dietary guideline. And same way here also I see we had to educate the general public. Already they are aware, but still if we can somehow educate them plastic to biodegradable and natural alternatives, I think we will see a better society down the lane.
Yeah, I think made a very valid point. Awareness is one, and then constant education to the public. But also what I see from a public is more of resistance in terms of using that, right? As an individual, we have to make a conscious effort to actually, avoid some of the single-use plastics, and see if we have an opportunity to actually, take some of the use mode of steel bottles, try to avoid more of, single-use bags, take your own bag. So at least those are come, but at least still people, as a convenience, it says, right, because lot of resistance is there, and we as a person has individually have to change, so then the society can come together and at least stop from avoiding. I think I'll give you an example. I was so stunned to I was this whole climate week happened. So if you attend one of the events, everybody's talking about how to solve climate problem, through a lot of green energy innovations and things like that, right? EV. But then when you actually go to the lunch, everything is like single use: fork, spoons, plates. So I was thinking, like, we are talking big things, but the small easy things to do is to at least stop buying those and then use a little bit more money to actually give bamboo or wooden based. So I think some of them, so that's what there is a contradictory approach which I see, right? We just talk in slides, but then action very, very less.
That transformation has to come from us individually, because you see, we need to practice. Whatever we preach, we need to practice. And as you rightly said, you see, now when we're talking about this climate change and then this sustainability and planet health, that should start from us. And then what is the point when I'm talking to you and then at the end I serve you everything in the plastic bags and then plastic pouches? I'm not ready by myself. I can only talk. So that is where I think it has to start from us, that
Right.
responsibility.
Right.
But one more thing, the general public also will accept this as long as it is convenient and then
Convenient.
inexpensive. Inexpensive. So the plastic is inexpensive material. See, for example, when you go to grocery stores, they they absorb the price of those bags in their profit, and then they give us, they say as if it is free. It is not free. Nothing comes for free. But general public mindset, if you see, oh, the bags are there, you can take as many as you can for your so they think it is free. So, but if there is a way we could reach the stage where will be able to give away those many bags, I think public will accept it without any hesitation. So that is where it is the responsibility of as a researchers. And I know the way you are doing, you are taking this information to general public through your podcast, which is really commendable. You are trying to educate them. Hey, you are trying to bring their awareness, saying that this is what is going on. So consider this. So this is also one of the, as I said, this dietary guidelines. You will see, you will not see the effect right away, but down the lane after 10 years
Right.
and 15 years, you will see the effect.
I think the policy also has to help. So I think more EU has been very strict in terms of the recyclable, and probably every organization to actually come up with more sustainable ways of working or packaging and everything, right? So I think the policy has to be also very strict across. I think what I understand is the regularized production is very easy to handle, but then the unregularized market, especially in Asia and India, there's a lot of plastics which is produced more of not really unregulated industries, right? So which is that it's difficult to contain those
No,
as
I
much.
don't believe
Yeah,
so. I don't believe so. Eventually, you will see, even though they are going to change. Why are they this unregulated market also people are using? Why? Because this is cheap, inexpensive, highly convenient one. But now, if you can show a way that hey, this is better, this is also equally inexpensive, then people will be able to afford it. People
right.
will that they will switch it. At this moment, we might think it is impossible, but I believe it is not impossible, because as long as you could tell them that this is also freely available, and then it doesn't cost much, I think people will switch very easily.
Because this is something which is very commonly available in the supermarket, right? So because we said the food, we have to at least look at how do we get to a state where we actually able to bring up something which is replacing whatever is touching the food, which is important, because a lot of plastics, microplastics and nanoplastics would get translated in the transportation. And but today we have no option. So I'm just giving an example. Okay, this is something which is in plastic. So do we think, is there a product which actually could mimic this quality to actually build something of that? So that is one question.
I'm glad that you brought that. In fact, we are working on in in that direction too. But now that we made films, and then we are trying to use them to increase the shelf life of fruits and fruits. For example, strawberries and raspberries. We showed that by using our films to pack them, we could extend the shelf life of
Right.
strawberries and raspberries
Wow,
by couple of days. And now we are
that's
also
interesting.
trying to use this biodegradable uh, as a coating materials to further enhance the shelf life. And one more thing is to make those boxes, those boxes. And then, because this, as I said, our films have really significantly, the better thing is, other way to say it is, it has very good strength.
Hmm.
So that's why we think we will be able to mold them to create a strong, durable boxes. And then once we are able to create these boxes, we believe that could enhance the shelf life of the product, anything that could be packed in it. So I believe it is doable, and we are working. And then we'll see, once we have some data, I can let you know. But I believe it is. We can.
I think it's doable for sure. As you said, I think the only thing is that as a consumer, we also have to consciously think and make an effort. The only point, which is a lot of times the greenwashing happens. People need to understand. Like say it says biodegradable. It is actually, we have to look at the time it takes to biodegrade. So whether it is actually 2 year, 3 year, 4 year, doesn't then it doesn't make sense to say biodegradable, because it is as good as staying in the soil for so long. So unless as something like of this, like from a cellulose or biomass, where it actually biodegrades, I don't even have to think about it after I put it in the soil. That's wonderful. I think you said something, even biodegrades in 7 days, or probably less than 10 days, right?
17 to 20, maximum month or two.
Maximum month, yeah. Mm.
If you have a moist soils, that's what we found out, that within a month or two. But if you have very low moisture, for example 12% moisture, if you have,
Mm.
even there it degrades, but it will take couple more
Couple
extra
more
months,
months.
three
Okay,
to four
that's
months.
fine.
That should be okay. And if you could add somehow moisture, for example, it rains one day, I think it disappears. The cellulosic films, especially those from the ag waste, the bio waste, I think that would be a solution for this.
Your dream application for your materials? Any?
My dream is to create a
Wrapping?
grocery bag.
Oh, the grocery bag. Okay, that's interesting.
That is what, because we use grocery bags every day, so that's
A
what
lot. Yeah. Important. I mean, I think it's an inspiration, right? It's a learning for everybody.
I know very little. That's what I can tell you. I'm still learning.
Yeah, I know. That's what I'm saying. You're very humble. One word your students would use to describe you. Dr. Jana.
They call me Dr. Jana. That's what I can tell you.
If we go this pace, what I see is we will be generating almost 2 million metric tons of plastic waste by 2050. So I'm not sure how much all the marine animal, like fish, every marine creature's gut is filled with microplastics and lead and whatnot, right? So I think it is coming back to us in the form of when you start eating them.
We will be welcoming every newborn with a lot of plastic waste if at least we solve this issue. We had to join our efforts and then come up with a solution. And I believe this cellulose could be one. Yeah, there could be some more that one has to pursue.
If you liked this conversation, please hit the like and subscribe button to get the latest updates from my channel Caffelogue with Naga. Thank you so much.